All right, let's get started with 0.2 integer exponents and scientific notation. So what are we up to? We're going to evaluate expressions involving integer exponents, things like that. We're going to apply properties of exponents that might look like that. And then we're going to use scientific notation, which might look like that. Okay. Conceptual objectives, we're also going to visualize negative exponents as reciprocals. So 5 to the negative 3. Oh, that's a bad negative. 5 to the negative 3. What does that look like? And understand the scientific notation is an effective way to represent very large or very small numbers. All right, here we go. So first things first, we're going to look at an exponent as being a shortcut for multiplying. So a to the n is a times a times a. And let's just, while we're at it, these are called, the three dots are called ellipses. Okay, and they indicate that the pattern continues between here and here. So since it's a times a times a, and then times a times a times a times a, as many times as necessary. So what does this look like? 4 cubed would be 4 times 4 times 4, which would be 16 times 4, and 16 times 4 is 64. How about 8 to the first? 8 to the first is just 8 times itself. Now remember, you can always say times 1 at the end of these. So 8 times itself, or just 8 times 1, is 8. 5 to the fourth, 5 times 5, 4 times. So that is 25 times 25, and that is 625. And then 1/2 to the fifth is 1/2 times itself 5 times. And the nice thing about this is that you're going to multiply all the numerators together. So what's 1 times 1 times 1 times 1 times 1? 1. And what's 2 times 2? 4 times 2 is 8, times 2 is 16, times 2 is 32. So 1/32. Okay, pause the video for a second. Go ahead and try these two problems. And hopefully we did this. 6 times 6 times 6, which is 36, times 6, which is 216. And 1/3 times itself 4 times. 1 on top, because 1 times 1 times 1 times 1. And then 3 times 3 is 9. And 3 times 3 is 9. So what's 9 times 9? 81. Hopefully we got that. Okay, how about when we have a negative being raised? So the pattern continues. Now, be careful here. This is where mistakes happen. Negative 3, in parentheses, is being raised to the 4th power. What that means is that negative 3 is multiplying 4 times. So let's see what happens here. 3 times 3 is 9. Negative times a negative is a positive. 3 times 3 is 9. Negative times a negative is a positive. There are 1, 2, 3, 4 negatives, an even number of negatives. So we're going to end up with a positive number. Now this one here, negative 3 to the 4th, the 3 is being raised to the 4th power. And then we're timesing negative 1 in front of it. Okay? Notice how the negative is not in the parentheses. Even though there's not parentheses, you can imagine 1 right there. The 4 only goes to what's right next to it. Okay? So in this case, we're going to say 3 times 3 times 3 times 3. Remember with PEMDAS, we're going to do exponents first, and then we'll multiply the negative 1. So 3 times 3 times 3 times 3 is 81, and times negative 1 is negative 81. Okay, so be very careful there. Let's see what's going on this problem. Negative 2 to the 3rd is going to be negative 2 times negative 2 times negative 2, which is 1, 2, 3 negatives. So our answer is going to be a negative. And 2 times 2 times 2 is 8 times 5 times 5, which is times 25. Now 4 25s gets you 100, right? 4 times 25 is 100. So 8 times 25 is going to be 200. And a negative times a positive is a negative. Your turn. See if you can get negative 4 cubed times 2 to the 3rd. All right. So negative 4 cubed is going to be negative 1 times 4 times 4 times 4 times 2 times 2 times 2, which is going to be 64 times 8. What is 64 times 8? Well, we can do it in the calculator, but we should be able to start getting good at doing things in our head. And so one way we can do that is say, what's close to 8 that's easy? How about 64 times 10, right? 64 times 10, we can do that in our heads, that's 640. But 10 is 2 more than 8. What's 64 times 2? Well, 60 times 2 is 120, and 4 times 2 is 8. So 64 times 8 would be 64 times 10 minus 64 times 2. So we take this away, 600, take this away, we're going to have 512 as our answer. And remember, there's a negative in front. Okay, what about negative exponents? So 2 to the negative 4th. Here's what this means. The negative means we're going to do the reciprocal. A negative exponent implies a reciprocal. So a to the negative n means 1 over a to the positive n. So 2 to the negative 4th is the same as 1 over 2 to the 4th. Okay? Now what you can do instead is say, what is 2 to the 4th? 2 to the 4th is 2 times 2 times 2 times 2. 2, 4, 8, 16. And since it was 2 to the negative 4th, we're going to say 1 over 16. We're going to flip it over. And that's what the negative means. So reciprocal doesn't just mean send it to the bottom. Reciprocal means flip it over. So if it's a negative in the denominator on the bottom, we're going to flip it to the top. So what is 3 cubed? 3 cubed is 3 times 3 is 9 times 3 is 27. It was in the denominator, which means now it has to be in the numerator. So it was 1 over 27. Now it's going to be 27 times 1. What's left over in the denominator? Just a 1. We could always say 1 times. So our answer here is just 27. The flip, the reciprocal of 127 is 27. Okay. So a little bit more complicated here on C. 4 to the negative 3 is 4 cubed, which is 1664. But since it's a negative, we'll put it in the denominator. So 1 over 64 times 2 to the negative 4 coming from the denominator is going to go to the numerator. 2, 4, 8, 16. Right? 2 times 2 times 2 times 2. We're going to say 16 over 1. And 16 goes into 64 4 times. So the answer here is 1 over 4. All right, and last one, negative 2 cubed. So we're going to say 2 cubed is 8. And there's a negative in front of it. That negative is not being raised to the 3rd power. Over negative 6 to the negative 2. Well, let's see. That's going to come to the top. So what's left in the denominator? Just a 1. Times, the 6 came to the top. 6 times 6 is 36. Negative times a negative is a positive. So we're going to say negative 8 times positive 36. And what do we end up here? Negative 8 could say 10 times 36 is 360. And 2 times 36 is 72. So let's take them away, and we'll have an 8, and that's it. When we take that off, that's a 5. We get the 8, so 288 with a negative on it. And again, you can plug that in your calculator. But just want to start thinking about how we could do this in our head. All right, give it a shot. So negative hanging out front, that means it's going to sit there and wait till the end. 5 is going to go to the top, so we're going to say 25, 5 times 5, over, is there anything left in the denominator? Nope, just a 1. So our answer here is negative 25. Okay? Note that the negative power here has nothing to do with the answer being negative or positive. It just means do the reciprocal. Okay? All right, so I could put a 1 underneath here. That's going to go to the bottom, and this is going to go to the top. So we're going to have 3 squared on top and 6 squared in the denominator. That's 9 over 36. Can we reduce it? Yes, we can. If you can reduce, you always need to reduce. Our answer here is 1/4. Okay. All right, now 0 exponents. This is going to be nice and easy for you. Anything in the world to the 0 power is 1. So what's 5 to the 0? 1. What's 1 over 2 to the 0? 1 over 1, or 1. What's negative 3 to the 0? 1. Now what's negative 4 to the 0? Remember, the negative is not being raised to the 0. It's 4 to the 0, which is 1, and the negative is hanging out in front. So the answer to the D is negative 1. Okay? All right. Let's move on to some quick properties of your exponents. So, some rules here. If the base is the same, we're going to add the powers if we are multiplying the exponents. Okay? So x squared times x to the 5th becomes x to the 2 plus 5 x to the 7th. The rule works for dividing the same way, but instead of adding, we're going to subtract. So x to the 5th over x cubed, bases are the same. We're going to say 5 minus 3. The answer is x squared. Okay? Now note that x cannot be 0 here. Why can't x be 0? Because if x was 0, we would be dividing by 0, and that is a no-go. All right? If we have a power raised to another power, we're going to multiply them. So x squared to the 4th becomes x to the 8th. And then we can also distribute. So if we have a power on the outside, it distributes into both terms on the inside. So 2x cubed becomes q cubed times x cubed, or 8x to the 3rd. And this is a huge common mistake. Oftentimes people will write 2x to the 3rd, forgetting that the first term also needs to be raised. And the last one that works the same way with distributing in a fraction, that n would go to both the a and the b. So something like this, x over y to the 4th, can be written as x to the 4th over y to the 4th. Let's see some examples in action. So what do we got here? We have, so problem like this. I'm going to take the regular old coefficients, negative 2 times 5, put them by themselves. And I'm going to put the x's by themselves, x squared times x cubed. And I'm going to put the y's by themselves, y cubed times y. Okay, what's negative 2 times 5? 10. What do we do with these? We're going to add them up. X to the 5th. We're going to add these up. What's our power here? It's a 1. So we get y to the 4th. All right. What happens here? We distribute into everything. So we get 2 to the 3rd times x to the 2 times 3 to the 6th. Y to the 1 times 3. Z to the 3 times 3 is 9. Let's evaluate this. What's 2 cubed? 8. So we have 8 to x to the 6th, y cubed, z to the 9th. All right, last one, we can divide. Let's split them up into parts. 25 over negative 5, x cubed over x to the 5th, y to the 6th over y to the 4th. Okay, 25 over 5 is 5 with a negative in front. Now here we're going to subtract. 3 minus 5 is negative 2, so this would be 1 over x to the negative 2nd, which means it would be on top, 3 minus 5 is negative 2, which means we send it to the denominator. Now, the way you can just think about this and more simply, without me confusing you like I just did, is which one's bigger? The 5 is bigger, so our answer is going to be in the denominator. If the bigger number was on top, the answer would be in the numerator. Okay? And let's subtract these. 6 minus 4 is also 2. Y squared, we put it in the numerator because 6 is the bigger number between 6 and 4. Okay, give it a shot for yourself. Pause the video, try these 3 problems. All right, let's see what we've got. Negative 3 times 4, x cubed times x, and y squared times y cubed is going to be negative 12, x to the 4th, y to the 5th. My parentheses there. Okay, b, negative 3 cubed, x cubed, y to the 3 times 3 is 9, z to the 6th, 2 times 3, and so this is going to be negative, because it's a negative times a negative times a negative, negative 27 x cubed, y to the 9th, z to the 6th. And lastly, negative 16 over 4, x to the 4th over x, y to the 3rd over y to the 7th. We're going to get negative 4, x cubed, 4 minus 1, over y to the 4th. Because 7 is bigger than 3, so that answer will be in the denominator. Okay. All right, so let's write an expression so all exponents are positive. That means any negative powers, we need to bring it either to the top or the bottom. So here, let's distribute. We'll have 3 to the negative 3. X to the negative 6, and y to the negative times the negative is a positive. Okay, let's just, before we even distribute this, what goes where? So, z is on top, 3 is on the bottom, x is on the bottom. And then we can clean up that 3, z to the 12th, over 27, x to the 6th. What's happening here? We have x to the 4th, distribute that 2 times 2, y to the negative 6, over x to the negative times negative is positive 3, y to the negative 12. All right, let's flip over anything that needs to be flipped over. So y to the negative 12 goes up top. And y to the negative 6 goes to the denominator. So y to the 6 on the bottom. Let's subtract. 4 minus 3 is 1. And 12 minus 6 is 6. And in both cases, the numerator 1. So the denominator would just be a 1, which you do not need to write. You can just write it as x times y to the 6th. All right, last one here, negative 2 cubed. X to the 3rd, y to the 6th, over negative, that's going to hang out in front of everything, 6 squared, x squared, z to the 3 times 2 is 6. All right, so what do we have here on top? Negative 8 x cubed y to the 6th, negative 36 x squared z to the 6th. The only thing that will cancel for the x's, for the variables, are the x's. So that would be x to the 1st on top, y to the 6th, z to the 6th in the denominator, and negative cancels a negative. And does 8 go into 36? Well, they're both even, so you could say 4 over half of 36 is 18. They're even again, so 2 over 9. You can divide them both by 4. So we'd have 2x to the 6th over 9z to the 6th. That's our final answer. All right, give it a shot. We would have t to the negative 3, v to the negative 6, over the negative 1 distributes 2 to the negative 1, t to the negative 4, v to the negative 3. So let's flip over everything that needs to flip over, which is everything. 2 on top, 2 to the 4th on top, v to the 3rd on top, t to the 3rd on the bottom, v to the 6th on the bottom. Our final answer is 2t over v to the 3rd, 6 minus 3. All right, we're going to finish up by talking about scientific notation. So scientific notation is a way of shortening what you have to write, especially with the zeros, right? So how many zeros do we see here? We see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we're going to keep going all the way over to here. So 13, 14, 15. We can write this as 3.856. That's 10 to the 15th power, right? So positive powers are going to get really, really big. Negatives, 1, 2, 3, 4, 5, 6 go just past the first important number that's not a 0. 2.75 times 10 to the negative. Again, how many do we move? 1, 2, 3, 4, 5, 6 times 10 to the negative 6. Okay. All right, quick technology tip. Once you get your your graphing calculators, sometimes you'll see something that looks like that. Okay, that's the graphing calculator way of saying 3.856 times 10 to the 15th. But E is the scientific notation on the calculator. The second one here would be 2.75 times 10 to the negative 6th. And so just be aware of that when you see it. All right, let's knock this out. Pause, give it a shot. All right, hopefully you got 4.52 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. And the second one, we're going to say 4.3 times 10 to the negative. We're going to a small number, 2, 3, 4, 5, 6, 7. All right, and let's just go the other way to finish things up. So on this one, we're going to move 2.869 and expand this 5 places. 1, 2, 3, 4, 5. What do we do with these empty places? You got it. We put in a 0. So we have 286,900. And we'll go the other way on this, 1.03. We're going to move it 1, 2, 3 places to the left. So we'll have 0.00, 2 empty spaces, 103. Your turn. 8, 1, 3 more zeros. Now I did that without actually having to do this thing because I knew it had to move once for the 1 and then 3 more to get to 4. So 81 with 3 zeros. Same thing here. I'm going to say point. How many zeros am I going to need? I'm going to need 7 because 1 move will be for the 3. So 1, 2, 3, 4, 5, 6, 7 zeros, then a 3, 7. All right, that's it. We will see you in class tomorrow.